This is going to be a brief overview of all of the hormones that you need to know for the MCAT, and we'll start with the hypothalamus. The hypothalamus releases hormones that travel through a capillary bed to the anterior pituitary gland. That then causes the anterior pituitary gland to release more hormones that go to one of these 4 destinations. A tropic hormone is a hormone that causes another organ to release more hormones. That means that everything released from the hypothalamus to the pituitary gland is a tropic hormone. Starting on the far left, the hypothalamus releases corticotropin releasing hormone. That then causes the anterior pituitary gland to release adrenocorticotropic hormone. That travels through the bloodstream until it reaches the adrenal gland, which is right on top of the kidney. It causes the adrenal gland to release cortisol. Cortisol is called a glucocorticoid because it has an effect on blood sugar. It increases glycogenolysis and gluconeogenesis. The next thing the hypothalamus releases is called thyrotropin releasing hormone, or TRH. That causes the anterior pituitary gland to release thyroid stimulating hormone, which then travels to the thyroid. That's going to cause the thyroid to release T3 and T4. These 2 hormones control metabolism, and the more that you have, the higher your metabolism is. Next, the hypothalamus releases gonadotropin releasing hormone. That signals the release of FSH, or follicle stimulating hormone, and LH. For males, FSH will increase sperm production, but in females, it's going to cause the maturation of the follicle. The follicle will then release the final hormone of estrogen. LH in males will cause the production of the hormone testosterone. And then testosterone causes male sexual development. And in females, it's going to cause the rupturing of the follicle, which then forms the corpus luteum, and the corpus luteum produces progesterone. Estrogen will cause the uterine lining to thicken, and then progesterone will maintain that thickness. I'll highlight all of the hormones in yellow that are tropic hormones because they cause a different organ to release more hormones. The hormones highlighted in red are direct hormones. And direct hormones will cause different changes in the body, but they don't directly cause another hormone to be released. The anterior pituitary gland does release some direct hormones, which we'll look at right now. It releases prolactin, growth hormone, and endorphins. The hypothalamus releases something called prolactin inhibiting factor, and as long as that's being produced, we won't release prolactin. Once it stops being produced, then prolactin will be released, and prolactin causes milk production, and that's in the mammillary glands. The hypothalamus releases growth hormone releasing hormone to cause the release of growth hormone. Growth hormone is going to cause many parts of the body to grow, so it increases cell division and energy usage. You don't need to know what causes endorphins to be released, but those are natural painkillers. Now let's look at the posterior pituitary gland. This one is much different because what we have here are neurons that start in the hypothalamus, travel all the way down, and then end in that posterior pituitary gland. The terminals of those neurons release hormones into a capillary, and then that capillary takes those hormones to their target. The big one that you need to know is antidiuretic hormone, also called vasopressin. This acts on the collecting ducts of the nephron and causes an increase of water reabsorption, and it's released whenever we are dehydrated. The other one that you need to know that's not near as important is oxytocin, and that's released during labor and it causes contractions. Now we'll look at more hormones released from the adrenal gland, and remember we already covered cortisol, which is a type of cortical hormone. The 2 big hormones that the medulla releases is epinephrine and norepinephrine. These are released during the fight or flight response, so naturally they increase things that you would need during a situation like that. That could be glucose usage, dilation of blood vessels that are going to help with muscle contraction or breathing. Another big thing they do is they increase breathing rate. With these, I wouldn't try super hard to memorize exactly what they do, but just think about what would you need to have happen if you were in a fight or flight situation. The cortical hormones that are released can be categorized as glucocorticoids, mineralocorticoids, and androgens. We already covered cortisol, which is a type of glucocorticoid. The mineralocorticoid that you need to know that is super important is aldosterone. Aldosterone acts on the distal convoluted tubule in times of low blood pressure. It causes the reabsorption of sodium, which then causes water to be reabsorbed. Androgens are male sex hormones, and they help mostly with male sexual development. You will find androgens in females, but in much lower levels. Testosterone is a type of androgen, but it's not produced in very high levels in the adrenal gland. Now we're going to look at the hormones released by the pancreas. Insulin is released in response to high blood glucose levels, and it helps the cells of our body take in glucose from the blood. It also promotes a lot of things in metabolism, like glycolysis, glycogenesis, and fatty acid synthesis. When blood sugar drops, the pancreas releases glucagon, and what glucagon does is mobilizes the body's stored energy. So it breaks down glycogen in a process called glycogenolysis, and it breaks down fat and promotes fatty acid oxidation. And the last hormone released is called somatostatin. What this does is it basically regulates the amount of both glucagon and insulin that's released to make sure that there's not too much of either of those released. Now we'll look at the hormones released by organs in the digestive tract. There are two released by the stomach. The first is gastrin. What gastrin does is it promotes the production of HCl in the stomach, and it's released in response to eating. The other one is called ghrelin, and ghrelin promotes hunger. The duodenum, which is what the stomach empties into, and it's the first part of the small intestine, once food reaches that, it releases a hormone called cholecystokinin. This hormone promotes satiety, and it encourages the release of pancreatic juices to help digest that food that just entered. While not related to the digestive system, fat tissue does release a hormone related to hunger. It's called leptin, and leptin also promotes satiety. The final organ we're going to look at is the thyroid and the parathyroid. The parathyroid are these small glands that we see on the thyroid. We already discussed T3 and T4, so we're going to look at the other hormones released by these organs. These hormones are related to calcium levels in the blood. When calcium levels are too low, the parathyroid glands are going to release parathyroid hormone. And this does a few things that are going to raise calcium levels. It's going to increase absorption in the gut. It will increase calcium reabsorption in the kidney. And the last thing, which is the most common thing they ask about, is that it stimulates these cells called osteoclasts that will break down bone and release that calcium into the blood. When calcium levels are high, the thyroid releases a hormone called calcitonin, and it does the exact opposite of each one of those things that parathyroid hormone does. So it decreases gut absorption, it decreases calcium reabsorption in the kidney, and instead of breaking down bone, it builds bone.